Assalamualaikum and salam sejahtera. Today we're going to share chapter 9 Chemical in Industry for student science form 4 KSSM. I am Puan Rosmawati, SMK Convent Ipoh. Please click like button and subscribe. Alloy. An alloy is a mixture of the several types of metal or a mixture of metal and non-metal by a certain percentage. Actually, alloy is a mixture between metals or the mixture between metal and non-metal. So many objects around us are alloy. For example, steel, pewter, bronze, brass, and duralumin. So all these thing is alloy, which is we are using in it around us. Now we want to see the example of alloy and their properties as well as their composition. So first we look at the steel. Steel is the composition is consists of electric ion, about 99%, carbon 1%. So the properties is hard and strong. The use of steel is a construction material for building and bridge, to make frame of vehicle and railway track. So this is the use of steel. So now we go for pewter. Pewter, the composition is 96% is tin, 3% of copper, and 1% is antimony. So what is the property of pewter? Lustrous, resistant to corrosion. What is the use of the pewter? To make decorative items such as a photo frame. Now bronze. Bronze is actually consists of 88% of copper, 12% of tin. The property of bronze: hard, resistant to the corrosion, and attractive color. So bronze color is the gold color. And the use of bronze is to make monument, metal sculpture, coin, medal, or others. So the third place, normally they put bronze, right? So this is the type of example of alloy. Okay, now the fourth alloy we're going to learn is brass. Brass, the composition of brass is 75% of copper and 25% zinc. So it's strong, has shining surface, malleable, gold in color. So to make key, door, knob, musical instruments such as trumpet. Okay. Last one is duralumin. Duralumin, from the word you know, is consists of the aluminium, which is 95%, copper 3%, magnesium 1%, and manganese is 1%. So the properties of duralumin is light, strong, and resistant to corrosion. So the use of the duralumin is to make frame of aircraft, aeroplane, and others. So since it is very light, so it's suitable for make the aeroplane. Why is an alloy is produced? Why we have to create alloy? So why? Because most pure metal are soft and can corrode easily. So alloy is a property. Alloying is a process to make alloy. So how to make alloy? The process to make alloy? The answer is alloying. So why we have to make produce alloy? Because most of the metal are soft, pure metal, soft and very easy get corrode. Okay. So alloying is done to improve the properties of pure metal. The atom in pure metal are arranged orderly in layer. So a layer of atom in pure metal slides over each other easily when force is applied. Okay, look at the diagram. So the first diagram is a pure metal. So when we apply force, so you can see the layer of the atom very easy slide over each other. So this property will make the metal are soft and very easy corrode. To overcome this problem, we are producing alloy. So by additional of metal or non-metal into pure metal make the layer of pure metal atom difficult to slide over each other. It is because foreign atoms have different size. This makes alloy stronger and harder than pure metal. Okay, now look at the diagram. So this atom of pure metal, which is brown in color, okay, so we add with the atom of foreign element, so maybe metal or non-metal. So when this atom is mixed together, you can see the foreign atom is between the pure metal atom. Okay, so when force is applied, the layer of atom in pure metal have difficulty to slide over each other because of the size of foreign atom. So the bigger size of foreign atom make to this atom of pure metal difficult to slide over each other. So it gives the hardened property of the pure metal. So now we learn about the superconductor alloy. So what is the superconductor alloy? Superconductor alloys are metals that conduct electricity at high efficiency without any resistance. So in this superconductor is able to conduct electricity but without any resistance. You know, when you use the normal wire, the conductivity of electricity, they are having very high resistance. But this superconductor alloy, they will reduce, there is zero resistance. Okay, a superconductor alloy is also able to resist at the magnetic field, causing it can float when placed on magnet. So this superconductor alloy, okay, it's able to resist the magnetic field. So when the when it's put on the magnet, so it can float on the face of the magnet. So that is the special about the superconductor alloy. First, it will highly efficiency by conducting electricity without any resistance. And secondly, it will float when it's placed on the magnet. So what is the use of this superconductor? Okay, use of the use of superconductor is used for a construction of the railway track of a high powered train, which can move by floating with zero friction. So this type of train is in the Japan. Okay, it's allow the train to move in high speed because the rail and the wheel of the train is not attached. Okay, so when we put the superconductor, so the wheel of the train will be float on the track, so there is no friction at all. So it make the train move at very high speed. So this is the example of the high powered train that we call it as a bullet train. Okay, the other use of the superconductor is magnetic resonance imaging or MRI machine. So this machine is used to trace the disease inside the patient body. Okay, so superconductor alloys such as niobium titanium and niobium tin are used in the construction of the MIR machine. Okay, so next subtopic is 9.2. We are going to learn about the glass and ceramic. The use of glass and ceramic already used in 5000 before Christ, right? So it's made of a silica. It is a compound that contains silicon oxide, exists naturally in sand. So actually silica we can found naturally in sand. Pure silica melts and liquefied at around 15,000 degrees Celsius. So meaning when we heat up sand until 15,000 degrees Celsius, it will be melt and liquefied. So we get the silica. Okay, so this is the photo of silica or sand, and we able to produce glass from a silica. Okay, now what is the use or the properties of the glass? Okay, so we have 4 types of glass actually. We have the fused silica glass, with the composition is 100% silica. The property is resistant to heat, chemically inert. Okay, so that's why we are store all the acid inside the fused silica glass, because it's chemically inert. Okay, so it's made of the 100% silica. So the next type of glass is soda lime glass. It's made up of the silica, calcium carbonate and sodium carbonate. So what is the property of soda lime glass? Is low melting point, easy to shape. Okay, so this glass very easy to shape, and they have very low melting point. So next type of glass is borosilicate glass. Borosilicate glass is made out of the silica, boron oxide, sodium oxide and aluminium oxide. So what is the property of borosilica glass? Is high resistance to heat and chemical compared to the soda lime glass. But then still, it cannot compete with the fused silica glass. Okay, so the next one, last type of the glass is the lead crystal glass. So it also is made out of the silica, because silica is the main material to produce glass. But this one, silica add with the lead 2 oxide and sodium oxide. So the properties of this lead crystal glass is low melting point and high reactive index. So what is the application of glass? Okay, what is the use of glass? Okay, on the other hand, we can say what is the use of glass. First, to produce bulb. Bulb is usually made of the soda lime glass because it's resistant to heat and it is easily shaped. Okay, so this is the use of the example of use of soda lime glass. Other one is a laboratory apparatus such as beaker, conical glass are made from the borosilicate glass because of its high resistance to heat and chemical. So it's made up by the borosilica glass. Okay, next we have this one. I'm sure everybody know, right? This is glass prism made of the lead crystal glass. Is used to study the dispersion of light because it has high reflective index. So because the property is high reflective index, so we use it to produce glass prism. And the other example of glass is transparent glass. Window allow light to enter in the house. So this is the type of glass, other type of glass. So we have learned about the application of glass. Now we learn what is ceramic. Okay. Ceramic consists of non-metal substance that is formed from heat reaction at very high temperature, made from clay. Main component is aluminium silicate. So it's inside the clay. So the glass just now in the sand, right? But this ceramic naturally we can found in clay. So in clay we have the main component is the aluminium silicate. Okay, it's able to withstand high temperature and high pressure. So it's also good insulator of heat and electricity. So this is the clay. In bahasa Melayu we call it as a tanah liat, clay. So now clay they are formed the ceramic. Okay, now we learn about the application of ceramic. Okay, what is the use of ceramic? Ceramic is ceramic tiles used for flooring, have a sparkling property to make the floor look clean and nice. So our tiles actually is made out of ceramic. Okay, next, ceramic is used to make denture because it is hardness and inert to the chemical. So we used to make this denture. Okay. And also we use tableware is made of ceramic because it's resistant heat and corrosion. So normally our tableware not plastic, it's not the plastic, it's made of ceramic, right? Okay, because it's very high resistant, heat resistant and corrosion. Okay, next we learn the next subtopic is polymer. Okay, what is polymer? Polymer is a large molecule formed by change of smaller molecule unit. So, polymer is a long chain of the smaller molecule unit. So, the smaller molecule unit we call it as the monomer. Okay, look at the word poly. Poly mean many. Okay, polyclinic. Okay, poly mean many. Polymer mean the combination of monomer. Okay, the smaller molecule is the monomer. Mono mean one, a unit. Okay, so this monomer combine and form a long chain of the polymer. So we have two type of polymer. One is a natural polymer. The other one is synthetic polymer. Okay, so this is the product that we use, made up from polymer. Okay, we can see tire, bottle, chair, okay, toys, okay, and BBC behind there. So this is an example of the polymer around us. Okay, what is a natural polymer? Natural polymer are polymer that exist naturally from plant and animal. It exists naturally. Okay, it's originally from plant and animal. So the example of the natural polymer is starch, protein, and natural rubber. Okay, so we go more further about starch. You know, starch is inside the plant, right? So it's a storage of the food in the plant. It's a starch, right? So the monomer of starch is glucose. Okay, so this glucose combine glucose plus glucose is will form a long chain. So this chain we call it as a starch polymer. So the use is to produce energy. Okay, so starch, we know starch is the source of energy in our body, right? So another natural polymer is protein. Protein, so the monomer of protein is an amino acid. If you still remember about when you learn about the digestive system, when you eat protein, so this protein will be digested into the simplest form is the amino acid. So we know that amino acid is the monomer for protein. So what is the example of what is the use of protein or amino acid? Is to produce blood cell and body tissue. Okay, now last one is natural rubber. Natural rubber, the monomer is isoprene. Natural rubber, we come from the rubber to make a rubber-based product. So natural rubber is come from the tree. Okay. Okay. Now, what is the meaning of the synthetic polymer? Okay, synthetic polymer are man-made. Okay, it's made up by man. Okay, man-made polymer using chemical substances. Okay, what is the example of synthetic polymer? The first one is polythene. The monomer is ethene. So you look at the name, right? Ethene, the monomer. So when it's form of polymer, the name is polythene. So what is use of polythene? To make plastic bottle, plastic bag and pail. And the other one, the second one, I'm sure you are familiar with this one. Polystyrene that you use to pack your food, right? Polystyrene. So the monomer of the polystyrene is styrene. Okay, so when it's form of polymer, we call it as a polystyrene. What is use of the polystyrene? To make packaging container of electrical equipment. Okay, and the other one is perspex. Perspex, the monomer is metachloride. Methyl metachloride. Okay, methyl metachloride is the monomer of perspex. Okay, so what is the use of perspex? Is to make aeroplane mirror, window of the vehicle, and also the glasses. Okay, so it's made of the perspex. Okay, and last example of the synthetic rubber is neoprene. Remember just now we learned about the natural rubber. Okay, the monomer is isoprene, but this one is a synthetic rubber. The monomer of synthetic rubber is neoprene. So what is the example of neoprene? The use of neoprene synthetic rubber is used to make glove, the black color glove, tire, and the shoe sole. So all this one is rubber, but it's not the natural rubber, but it is a synthetic rubber. Okay, now we learn about the process of polymerization and depolymerization. Okay, the polymerization is a process to build up the polymer. Whereas the depolymerization is the process to break down the polymer. Okay, polymerization is a process of joining the monomer to form chemical bond to produce polymer. And depolymerization is a process of splitting a long chain polymer into its monomer. Okay, so look at the diagram. So from monomer to produce polymer, the process is polymerization. But from polymer, you want to break it down into monomer, the process is depolymerization. So these two processes, you have to remember, from monomer to polymer, we call it as the polymerization. From polymer breakdown into monomer, we call it as a depolymerization. Okay, now you look at the addition polymerization. So the other process is addition depolymerization. This is in the ethene. You remember or not polythene just now? Ethene, they have a double bond. Okay, you can see between C atom, carbon atom, CC is a carbon atom. Between these two carbon atoms, you can see double bond. Okay, so additional polymerization, so this double bond become single bond. Okay. Okay, additional polymerization is a polymerization that involves a monomer of the same type by breaking a double bond into single bond. So addition polymerization actually is referred to the double bond break up into the single bond. Okay, now we go more further about the natural rubber. It is a latex. Okay, so it is example of natural polymer. Remember or not, just now we learned about natural polymer. It is the example is a starch, protein, and the natural rubber. Okay, so from the rubber tree that we call it as a latex. Latex is a process into latex is a processed into natural rubber. So we have to process latex and it will form a natural rubber. So this natural rubber good for economic growth of our Malaysia country, our country Malaysia. So what is the property of natural rubber? So this natural rubber is elastic, soft, cannot withstand with heat, but it's good electrical insulator and not permeable to air. So this is the property of natural rubber. Okay, since they are not permeable to air, so we are using the natural rubber to make balloon. Okay, and it's elastic, right? So it's impermeable of air, so we can make a balloon from a natural rubber. So now we learn about the more detail about the rubber molecule. Okay, latex is the name of the rubber molecule in form of chain are covered with a layer of protein membrane. So that you remember our topic is still in polymer. Polymer is a long chain of the monomer. But in latex, this long chain of monomer is covered by a layer that we call it as a protein membrane. So the protein membrane, they have charge. So negative charge surround around the outer surface of the membrane, protein membrane. So we can say that the protein membrane is negative charge. So because of the rubber molecule is in the protein membrane, so this each of the rubber molecule will be repel each other because they are same charge. So negative and negatives will be repel each other. That's why the rubber is not coagulate. That's why latex remain in liquid form. It's not coagulate. Okay, look at the molecule of the diagram of the molecule rubber. You can see the chain of the polymer, rubber polymer is inside the protein membrane. So around the protein membrane, we have a negative charge. So you look at these two molecules of rubber. Each of them is a negative charge. That's why they are repel each other. So it will remain the latex in form of liquid. So now we learn about the action of acid on latex. So when acid is added to the latex, what happens? The positively charged of hydrogen ion, actually acid they are having hydrogen ion which is positive charge. So this positive charge will neutralize the negative charge of protein membrane of the rubber molecule. You know, positive charge will neutralize the negative charge of the protein membrane. So what happens? Rubber molecule will be attract each other because they have no more charge, right? So the rubber molecule will collide with other. So it will break the protein membrane. So now rubber polymer coagulate to form solid lump. So that is no more in form of liquid. Okay, look at the diagram. Okay, so now actually the original protein molecule is a charge, negative, right? So both charge is a negative, so they are repel each other. But when you add acid, this acid are having hydrogen ion. You know that hydrogen ion is a positive charge. So this hydrogen ion will be neutralize all the charge around the protein membrane. So now the protein membrane will be collide each other. So it will break down the membrane. So now the chain of the rubber polymer will be coagulate. Okay, so it's a form of the solid lump. It's no more in the form of liquid. So we learn about the action of alkaline on latex. Just now, action of alkaline of acid on latex. Now alkaline. So we know that alkaline, okay, are having a negative charge. Okay, acid are having a positive charge. So latex left without additional of acid will over time form solid lump due to the action of bacteria that produce acid. Acid from bacteria will naturalize the protein membrane of rubber molecule. So this one actually they wanted to explain to you about when you are not added acid to the latex, but this latex will be naturally collide or form solid. Why? Because the bacteria surrounding at the atmosphere will produce acid. So this acid will naturalize the membrane of the molecule. So it will be the molecule of latex will be coagulate, right? Even though we not added the acid. So somehow if we not added acid to the latex, it still will be clumped together because of the bacteria. Okay, so how to prevent it? So we have to add alkaline. So what happened to the action of alkaline on latex? Okay, so when an alkaline added to the latex, the hydroxyl ion. So this hydroxyl ion is a negative charge. Okay, hydrogen ion is positive charge, but this hydroxyl ion, it is negative charge. From alkaline will naturalize the hydrogen ion from the acid of the bacteria. So when we added alkaline, the hydroxide ion were helping to naturalize the acid that produced by bacteria. Without acid, negative charge remain on protein membrane and the rubber molecule repel each other. So rubber molecule is remain liquid. Meaning to ensure the latex remain in liquid form, we have to add alkaline. Because alkaline is negative charge. So when there is the bacteria come, so this alkaline will naturalize the acid that produced by bacteria. Okay, look at the diagram. Okay, this is a naturalized by a rubber particle, right? Positive charge from the acid due to the action of the bacteria. So when you add alkaline, so negative charge from alkaline, which is hydroxide ion, will be naturalized the positive charge of the bacteria. So the protein membrane will remain negative charge and they are repel each other. So they are still in form of liquid. So last one, we learn about the vulcanization rubber. So this is a process, vulcanization rubber. So vulcano, you remember the word vulcanize, right? Vulcanize or gunung berapi. Okay. So natural rubber, you know that the properties of natural rubber is soft and not resistant to heat. Unsuitable material for tire vehicle. So it's not suitable for making tire, right? And it's soft. You just imagine if your car's tire is made out of the natural rubber. So it's not resistant to the heat. So when you want to travel from Ipoh to Kuala Lumpur, what happen? So all your tire will be melt. Okay, so it's not suitable to make tire from the natural rubber. So what to improve? There are produce the new invention that we call it as a vulcanization rubber. So vulcanization can improve the property of the natural rubber. So vulcanization is a process of heating rubber with sulfur. Okay, so you have to heat the rubber together with the sulfur. Okay, sulfur atoms are added to the chain of the natural rubber polymer molecule. So we call it as a vulcanized rubber. So what is the process? Vulcanization. Okay, but what is the name of rubber after added sulfur? The name is a vulcanized rubber. Okay. So now we look at the net structure of the vulcanized rubber. What is make the rubber more resistant to the heat? Okay. The added sulfur atom produce cross-link between the rubber polymer chain. Okay, when the force is applied, difficult for the chains to sludge each other. So when the heat applied, the structure of vulcanized rubber is difficult to break because it's made up of the sulfur. So we found the sulfur in the vulcanized mountain, right? It's very resistant, can withstand with the high heat. Thus, it's become hardened and has high resistance to heat. Suitable for making tire. So look at the diagram. So the first diagram, chain of the natural rubber. There is no link between the polymer chain, right? And it's very easy to sludge each other. It seems like the alloy just now. Okay. So when this chain of natural rubber is added sulfur, you can see the sulfur cross-link between, the sulfur will form the sulfur cross-link between the polymer chain. So this sulfur cross-link will make the vulcanized rubber more harder and more resistant to the heat. So this rubber are suitable to making tire. Okay, now we look at the properties of vulcanized rubber. First is hardened and more elastic. Even though they put sulfur is much more elastic than the natural rubber. So it also good electrical insulator because we can and difficult to be oxidized in air. You know the natural rubber very easy oxidized. It will turn to the solid form. But this vulcanized rubber difficult to be oxidized in air. That means it's not react to the air. Okay. The other properties of vulcanized rubber is does not react with acid and as well as alkaline. You know that natural rubber is very sensitive to acid and alkaline. Okay. Properties of vulcanized rubber are not permeable to liquid and air. So it also non-permeable of liquid as well as air. And also resistant to heat. So we know this natural vulcanized rubber already improve the property of natural rubber. Okay. Okay. So what is the latest rubber-based technology? So the use of the vulcanized rubber. First, Kaplam modified asphalt. Okay, CMA. It has a concrete asphalt on the pavement to last longer, resist heat, reduce noise and road crack. So now our road, we are made it from the CMA. Before we are tars the road with a bitumen only, but now we are use a rubber, vulcanized rubber, add with the bitumen asphalt. So we already modify it so it's more last longer, heat resistant, also can reduce noise and crack. So That is the use of the rubber. The other one is getah color, is a paint produced from latex to be used for visual art. So this one actually is make the color can last longer, it's not faded. Okay, so the color we call it as a getah color. The other one we use to make the rail pad made of the rubber is placed between the railway and the train engine to reduce vibration and sound. Okay, so that is the use of the rubber. Okay, thank you for watching. I hope you understand and don't forget to subscribe. Bye.